Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps and the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so a crossover question on exchange rates. Now, if you've seen any of my other videos, you'll know that I really love a box and label when we've got a fact in the question. It just gives me structure and makes it easy to solve. So the first thing I'm going to do is set up those boxes and labels. Now, we're being told that in 2010, Eric changed £600 into rupees. So into my pounds column, I will be putting my 600, and I'm putting it into this grid because this is the information on the year 2010. And I could label that if I wanted to. How does this work? We just multiply across the diagonal. So we're going to be doing 600 times 67.1. And then we would divide by the number in the corner. Now, dividing by 1 isn't going to make a massive difference here. So you might not even want to show that. Put that in your calculator and you get this. Now we want to work out how many pounds he'd have to change in 2012 to get the same number of rupees. The same number means that in our rupees column, we're going to put our previous answer. Now remember, we multiply across the diagonal and we divide through. We can see that the multiplying is multiplying to 1. Don't really need to show that. So we will just finish it off by doing the division. So our answer is 488. Okay, another crossover, very wordy. So with these types of questions, we just want to read it through carefully. And in most cases, we can do it just step by step. Now, as you read through this and you're picking up all that information about your cakes and your sausage rolls, you get to this point where it says Ali wants to buy more than 60 cakes. And it's really important that we clock that more than 60 cakes, more than 60 sausage rolls. So when we start doing the maths, we don't kind of mess up. He also wants to buy exactly the same number. So it's got to be more than 60 and exactly the same number. So I'm going to go back up to the cakes information. Cakes are sold in boxes. So I'm going to draw a box, and there are 12 in each box. And each box costs £2.50. Now, if I was to times my boxes up by 5, that would get me 60, which is no good because it must be more, remember. If I times through by 6, it will get me 72. So what I want to do now is look at my sausage rolls, okay, which are sold in packs of 8 at £1.20. So I've got that key information kind of in a picture. It's easy to process when it's looking like that rather than sentences. I know it's got to be the same. So can I times my 8 by anything to equal 72? And I can check that in my calculator, or if I know my 8 times table, I will know that it's times by 9. So now all I've got to do is work out the cost. The least amount of money that Ali will have to pay is the cost of 6 packs of cakes. So I'm going to times my £2.50 by 6, which gets me 15. My £1.20 by 9, which gets me £10.80. And to finish off, we just add those two totals together. Okay, a crossover question. We've been given a right angled triangle where we have 2 of the edges and we need to find the third. We've got to work out BC to 3 significant figures. Now, this is Pythagoras. Pythagoras is on the formula sheet. So you've got that information to help you, and you can just go to your formula sheet, find the formula, and then you can set this all up on your page. Now, there's a really nice way of doing this. If you go to the right angle and put little arrowheads on it, it points to 2 of the edges, points to these 2 edges. Those edges are your A and your B. I love colour in maths. It can make such a difference. So I know that we've got 9 squared plus 6 squared, and I could put that in any order, and that equals the length I haven't highlighted, which is the length that we want to work out. So when I put that in the calculator, I get 117. You could, if you wanted to, call that BC, which is what they're asking about. You could label it X. You could keep it as C. It really does not matter. What I do need to do is get the length, however I choose to label it on its own. And at the moment, it's got that power 2. So we're just going to pick that power 2 up, move it to the other side so that my edge is completely on its own. When it lands as its opposite. We pop that into our calculator, write down a decent amount. I always do 4 decimal places, or I generally do as a rule, so that the examiner can see that was what was on my calculator display. Now, 3 sig figs means I'm just going to count in from the start. 1, 2, 3. That means I cut it here, box off that one. Is it 5 or more? No. So I keep the answer as 10.8 centimetres. Okay, a crossover scatter graph question. What type of correlation does it show? Well, this is a nice, simple question for 1 mark. The points are all going in a downward direction, which means it's negative. The second part is telling us that the time a car takes to go from 0 to 60 is 11 seconds, and we've got to estimate the maximum speed of this car. So 11 seconds is here. What we're going to be doing is putting on a line of best fit. That will get us the first mark out of the 2 that we've been allocated to this question. And what you want to do is pop a straight line on that kind of hugs as closely to the line all of these points. So everybody's line will be slightly different, and they do allow a little range in the answers to allow for that. Now, all I'm going to do is go up at the 11, come across, and I'm coming out at exactly 120. So 120 goes on the dotted line. Any answer, I'll put it here, between 117 to 123 would have gained the marks. If you only write the answer, there's nothing here to show how you got it. You will only get 1 mark. So remember to use your marks to help you put enough down in your answers. Okay, we have a question about car parks. We can see that they're introducing algebra right away with this question. If South car park has X spaces and North car park has 48 more than South, then we would be able to write North as the same as South plus 48. If we've been given an expression, even though it's the smallest possible expression you can get, we're going to be writing expressions for everybody else. Central car park has 4 times as many as South. So 4 times the X, but obviously we want to show that as 4X. The total number of spaces in South car park and Central, so that's those two together, is more than twice the number of spaces in the North car park. So we've got to unpick that. Total spaces of South, which is X, and Central, which is 4X. So that is together 5X. More than is our inequality symbol. And then twice. So really, we now need to multiply that through by 2. Now you can start that off with the bracket, or you could just go straight in with doubling everything. Now we're going to go on and solve. First thing I'm going to do is get those X's together. So my 2X will move. It's positive. It's a positive term. It's a number I don't know, but what I do know is it's positive, which means it's going to land as negative. That is going to give me 3x being greater than 96. Then we divide through by 3, which gives us x is greater than 32. Now, what we've got here is that x has to be greater than or more than 32. And we want the least possible spaces, but it has to be more than 32. So our answer is 33. That's the least possible spaces in our South car park. All right. South car park is X, and X has to be more than 32. So it's 33. Some people can find that tricky to wrap their head around. So hopefully I've explained that well. Okay, another algebra question. We've got the perimeters of these two shapes being the same, and we've got to use that to help us work out x. Well, the first thing we're going to need to do, obviously, is work out the actual perimeter as an expression. We've, at the moment, just been given some edges. So the perimeter of our rectangle will be 30, will be 3x plus 4. And obviously, we've got another side that equals that as well. We've got our 2 4x's. Add up all your x's, add up your numbers, and that is our perimeter for the rectangle. And we're going to do the same for the trapezium. Now, they're telling us that the perimeters are the same. The perimeter of the rectangle is equal to the perimeter of the trapezium. And now it's just a case of solving the equation that we have set up. Going to get the x's together on the same side. I am going to move the smaller set of x's. If I move this, it means I'm going to be taking 14 away. It's going to leave me a positive term. Whereas if I do it this way round, I'll be taking 18 away and getting a negative term. So I'm just choosing to do it in a way to avoid a negative. The reality is it doesn't matter which way you do it, you will still come out with the same answer. So I've got 8 left on that side. I've got 4x minus 6. If you don't like things back to front, then you can rewrite this as 4x minus 6 equals 8. Hopefully we're comfortable with doing it in either direction. I want to get x on its own, so I'm going to add the 6, which is going to give me 14. And then I'm going to divide through by the 4. So x is equal to 3.5. Now, in the second part, we are being asked to write down the length and width of the rectangle. So the length of the rectangle is 3x plus 4 in algebra. We now know that x is equal to 3.5, so we're going to use that. So we're going to be doing 3 times 3.5 plus 4, which is 14.5. And then we've got 4x for our width, so nice and simple. You can either write that with a bracket, or you can write it out showing the times sign. It really depends on how you've been taught to do that, as to what feels natural. And that will give us 14 for the width, which we would just pop on the bottom, on the dotted line there, look. Okay, so our next question is a probability tree question. Very wordy. And we get that a lot with probability questions because they like to give some context. They like to give story and background. We really just want to focus in on the maths itself, okay? Now, we're being told that when the damage is minor, so here we have our damage and we have our minor. So this part of our tree diagram, this branch, when the damage is minor, the probability that there's an insurance claim is 0.2. So we've got our claim being 0.22. To not claim means it's 1 minus 0.2. One or the other is going to happen. That's a certainty. So that's where we do that 1 minus. And then for the second line, we kind of repeat the whole thing. When it's severe, we've got our severe. The claim, there's our claim, is 0.74. And 0.26 for no claim. For the second part, we're being told that the insurance company will increase their charges if the claims for damage is greater than 50%. So we've got to look at the probabilities of a claim happening. If there's a minor damage, there is a claim, and we pick up these two results and we multiply them together to get the overall probability of a claim when there's a minor damage, which is 0.121. We're going to do the same when it's severe. We've got the claim here being much higher. So we're going to again use those two values. We then take those two results, add them together to get a total probability. Okay, that is under 0.5. It is not 50% yet, so we can say not yet, or no, they don't need to increase, whatever language you want there, but make sure you do answer the question. Okay, so a crossover question here. It's simultaneous equations. Whenever we are doing simultaneous equations, I would encourage you to make sure that the first terms, which generally x, but they don't have to be, make sure they're the same, and they are. They are both a single x. So we've got 1x in each case. When they're the same, we can go straight into taking away each of the terms. So x take away x, we have no x's left. If I've got 2y and I take away a negative y, and we have to be so careful here. If I've got a takeaway and a negative number, those two negatives are going to be creating, creating a positive. So I end up with 3y equaling, and then I've got 3 minus 6, which will give me minus 3. Divide through by the 3 because I want to get y on its own so that I know what it is equal to, and y is equal to -1. And remember, you've got a calculator. It's a calculator paper. So if you need to be using your calculator at any stage, please do. Now we're going to substitute this value into one of these equations. It really doesn't matter which one you choose. I'm going to choose the bottom one. So we've got x minus y equaling 6. I've got x minus 1. Y is minus 1. These two negatives are going to create a positive. X will need to be 5 in order for that to be true. And you would just pop those results on your dotted line. Okay, so we've got a crossover question. It's got fraction and a ratio kind of screaming out of the question, hasn't it? So we've got Colin, Dave, and Emma sharing some money. We don't know how much money that is. We could put a question mark. For reminders, we don't know that. Colin gets 3/10, which means that Emma and Dave must get the other fraction. They must get 7/10. So Emma and Dave together must get that. They share whatever this sum of money is in the ratio of 3:2. So I'm going to get that set up and coded straight away because I know that I'm going to need that. Because this is a share question, I know that we're talking about some money, don't know how much, but what I'm going to do is I'm going to use a total column. If they had 3 and 2, they'd have a total of 5 between them. All right, but we know that they actually have 7/10. So I need to know what goes here to create the 7/10. And the way I'm going to do that is look at what multiplies. So 5 times something will give me 7/10. To work that out, I would do 7/10 divided by the 5 in my calculator. And the calculator tells me to times by 0.14. So I'm going to do the same on the other side. If I look at the question, I do really only need to work out Dave's share. So that would be 2 times 0.14, which is 0.28. You could write it as a fraction. So they will get 0.28 or 7/25 of the money. Okay, another crossover. We've been given the nth term of the sequence as n squared plus 4. Alex says the nth term of the sequence is always a prime number when n is an odd number. So really clock that. N is going to be odd. Alex is wrong, so that's a fact. And we've got to give an example to show that. Now, possibly the best way to approach this so that you're not jumping around all over the place is to just take a very systematic approach. So let's do the first odd number and see what we get. That is prime, so that is not an example. It's not going to help us. And we're just going to keep going like this. We've got the calculator. We can just throw it in. That one's prime. Now, when we get to this one, you might not know whether that is prime or not. And you can use your calculator, divide through by, a few numbers to see whether or not you are getting a whole number out. It is a prime number. And when we put 9 squared in, we definitely find our result that proves he is wrong, because 85 has to be in the 5 times table. Okay, so question 11 is showing a triangle, ABC. We've got to work out the size of angle A correct to 1 decimal place. Now, this is not a right-angled triangle. So this is going to be our advanced trig. Now, look at the formula sheet. Okay, I'll just bring that down so that we can see it clearly. The formula sheet has everything that you need. Now, this is going to be solved either by the sine rule or the cosine rule. We don't need the area. It's not an area question. So we need to take a good look at our question to decide which one it's going to be. We're being asked to work out the angle A, so we'll mark that on. Angle A is sandwiched between these two. That's our angle A, which is opposite this side here. This is going to be cosine. I always look for the sandwich. If I've got the sandwich and I've got the opposite, I know that I will be able to use my cosine rule. So let us copy it down. So you've transferred the information from the formula sheet to your question, and now you can start substituting everything in. Now, your a squared and your cos a are opposite each other in the triangle. We've got that color coding it, so hopefully it's really easy and clear to see what numbers are going to go where. So we've got 3.6 squared. B and C are these two edges. In either order, it does not matter. So we're going to substitute the rest of it in. And then we're going to use our calculator to start tidying this up and getting some results. Next thing I'm going to do is just get that total and then divide it through by this. And I will just show that's the plan by bringing this across as well. So I'm going to put all of that in my calculator. It's going to give me minus 0.25. That is equaling cos A. So now I just need to get A on its own, bring that cos across. It will land as its inverse. Pop that in your calculator and you have got 104.477. Feels good because I can see I've got an obtuse angle, I've got an obtuse result to one decimal place, and we're done. In the second part of our question, we are being asked about the area. So we can go back to that formula sheet and you will copy down a half AB sine C. And I would just say that this formula sheet is available for anyone taking their exam in 25, 26, or 27. If it gets extended beyond that, we're not in a place yet of knowing. But at the moment, we've got it for the next 3 years, which is wonderful. All right, substituting in. Now, our A and our B and our sine C has sort of changed a little bit, but it's still the sandwich. Okay, if I go back up here and we look at the formula sheet, we've got A, B, and then we've got that C sandwich between it. All right, so for us here, this has now become the C because we want the angle. All right, try not to either redraw it and put the letters on where you need to see them, but try not to let that overcomplicate things for you. Now, this is still actually on my calculator, so I don't need to use a rounded version. I can literally just use my answer key as I type all of this into the calculator in one go. And I will get that, which to one decimal place is 2.4, which we pop on our dotted line. Okay, so this is a bounds question. So the first thing we need to do is to write those lower and upper bounds for each one of our values. Now, the first one is where I think most people could make a mistake. We've been told that D is equal to 190, correct to 3 significant figures, and it would be really tempting to do a kind of number line that goes up in zeros in multiples of 10, like it's been rounded to the nearest 10, but it's not. It's correct to 3 significant figures, which means that it's given to the nearest whole number. So we're going to have like a whole number line, basically 189, 190, 191. So what I mean by that is when you've worked out how it's been rounded, you create your number line, and your upper and lower bounds are those midpoints. I can now write my bounds. And correct to 1 decimal place means I would be on a 1 decimal place number line. Now it says by considering bounds. When you read that, it means that you will have to do every possible combination so that you can then look and compare at all 4 of those results. So that's what we're going to do. Set them all up, pop them in the calculator and get our results. Okay, so I've written mine down to 4 decimal places. That should be enough for me to be able to see what's going on. And then I've got to find the rounding point where they will all come out the same. That's how I will find a suitable degree of accuracy. So for example, if I was to cut at 2 decimal places, that would give me 7.39. But I can already see that I'm not going to get a match because of this one that's come out with the 7.4. That would be 7.42. They are not the same. So what happens if I cut to 1 decimal place? 1 decimal place here gives me 7.4. 1 decimal place here gives me 7.4. 1 decimal place, 7.4. And we're getting it again here. So my suitable degree of accuracy is 7.4. And my reason is because all calculations round to this number. And you would write that down, make sure that's clear. Okay, our next question is mass, density and volume. So let's get our triangle done. Mum's on top. Mass, density and volume. And you can see that the units of our density is mass divided by volume. So in this question, our density is grams per centimeters cubed. And that just helps you make sure you get your numbers in the right places, really. Okay, so we've got 3 liquids in the story. We need to be organized with the information. So for liquid A, we've been told there's a density of 0.7. For B, our density is 1.6. We've got 140 grams. We've already checked in with that. Our grams is our mass. So we've got a mass of 140 for A and a mass of 128 for B. They're mixed together to make liquid C, and we've got to work out the density. So we need to know the density. We know the mass is A and B mixed together, so we add that to get 268. We have to have the volume for C in order to work out the D, the density that we're after. That means we're going to come back over here and we are going to be working out the volumes. Our triangle says is mass divided by density. So once I've got those 2 volumes, I just add them and then that will be my total volume for C. And our density is mass divided by volume. Just written a few decimal places so I can make it really clear to the examiner what I'm looking at. It doesn't say how it wants me to round, so I am going to do 3 decimal places just to be on the safe side. That would go on my dotted line. Okay, our next question is a functions question. The first part for 1 mark, really straightforward. We are going to be replacing our x in the function with the 3 that they've given us. So we will have 2 times 3 plus 5, which is 11. We've even got it on a calculator paper. When we've got to write the inverse function, the best way is to write the function, instead of using f of x, use y, and then swap the 2 letters around. Just rewrite with the letters in opposite positions, and then you will rearrange to get y back on its own. So we would take off 5, so x take 5 now equals 2y. We would divide through by the 2, and that gets you the inverse function. Best way of doing that. Okay, now we've been given another function for g, and we've got to find minus 3. So minus 3 squared minus 25 will give us 9 minus 25, which is minus 16. Be really careful here. If you don't put this into brackets when you're using your calculator, it will give you a completely different result. So be very mindful of that. Now, part D says we've got to find g f of x, and we've got to simplify as much as possible. What we're going to be doing is we are going to be taking our function of g, so this function here, and we're going to drop the function of x into it. So I've got, and I'm going to do it in full so you can see what's happening. So I've got this function. I'm then going to drop f of x into that function. And now everywhere there's an x, and in this particular question, there's just the one here, I will replace it with 2x plus 5. Now, all of that replaces the x, which is squared. And now I can go on and I can start expanding that bracket and bringing everything together. So you will use whatever method you have. I'm a crab's claw kind of person. And you will expand that. That tidies up to give 4x squared plus 20x plus 25. We've also got this minus 25 on the end there, so we're going to be taking that off. And that would give 4x squared plus 20x. Now, we can simplify that further by dividing through by 4. And that would give us x squared plus 5x. But it does actually say OE on the mark scheme, which means or equivalent. So you could have stopped here and still got full marks. The last part of this is to solve gf of x. Well, we know that gf of x is now x squared plus 5x, and we're being told it equals 0. So we've got to solve the quadratics. Already set to equal 0, which is what we need a quadratic to do. So we're going to factorize. X will come out. I know this one will be x equals opposite sign, so negative 5. And this x will equal 0. Okay, our next question is a probability question. We've been given some information about 20 sweets. Phil is going to take at random 2 sweets from the bag, and we've got to work out the probability that the sweets will not be the same colour. So that means that I could have an orange with a red or a red with a yellow, but I cannot have orange. Okay. However, that said, there are by far more combinations of 2 different sweets than there are 2 the same. And in order to answer this and save myself a little bit of time, I am going to use the 1 minus trick. If I work out what the same colour is, of which there are fewer options, and then I do 1 minus that answer, so 1 minus whatever the same colour is, it will give me the result, the probability that I'm after. I could draw a complete tree diagram to help me solve this. But I think once you start getting into this level of mathematics, you should be able to just pull the bits that you need to help you solve it. So in my first pick, if it was going to be an orange, it would have a 5 out of 20 chance. And then my second pick, if it were to be orange, would be 4, because there's only 4 left out of 19. And then I'm going to do the same thing for the other colours. So for red, I've got a 7 out of 20. And for the second pick, 6 out of 19. And for the yellow, 8 out of 20, and then 7 out of 19 for the second pick. So that gets me all the fractions that are involved. Now, remember, in a tree diagram, we multiply across. So to get the probabilities of each of these outcomes, I'm going to multiply the fractions together. Now, I need to do 1 take away all of the fractions that I've just found. Now, I could add those together and then show the examiner that I'm taking away that total, or I can set it out like this. It really doesn't matter. As long as the communication of what you're doing is super clear, your examiner is going to be happy. And the final answer is 262 out of 380. Your calculator might cancel that down. So any equivalent is acceptable. And that is just taking a slightly shorter route to the answer. Okay, for question 6, p is inversely proportional to the square of x. So the first thing that we want to do is write that down as part of an equation. So p is equal to k over x squared. So when we're inversely proportional, then we've got k divide. When it's directly proportional, that's when we've got k times. So it's k divide in this case. We're going to put the information that they've given us in so that we can work out k. Okay, so we've worked out that k is 150. We've got to find the value of p when x is 8. So we now have p equals 150 over x squared. We're going to substitute in the 8, which is obviously going to give us 64. 150 divided by 64, you pop that in your calculator. Show some of the digits that it's being displayed. We're doing it correct to 2 decimal places, so it's going to cut here. There's no rounding required, and that will be our final answer. Okay, so Fred is making 2 rectangular flower beds, and the dimensions of the larger rectangle will be 3 times the dimensions of the smaller rectangle. So I would automatically draw out my smaller one, draw out a bigger rectangle, and just show that it's times 3 bigger. Get that in. So I know I'm looking at similar shapes here because they've been multiplied up by the same scale factor. So that's something to really clock as early as we can. There is going to be the same depth of soil in each flower bed. For that reason, I don't need to be considering the depth in this problem. Fred needs 180 kilograms of soil for the smaller flower bed. So to cover this flower bed, we need 180 kilograms of soil. I've got to work out how much soil Fred needs for the larger. So we need to know what that area is. Now, when we're doing scale factors with similar shapes, the thing to remember is for length, you've got length, area, volume, scale factor squared, and scale factor cubed are the links that help you solve the problem. Now we can see that the length has been scaled up by 3. So our scale factor is going to be, remember, scale factor squared, because we're going from area to area. So it's going to be 3 squared. And when we pop that in, we get our final answer, 1,620. Okay, our next question is a histogram. We've got to work out an estimate for the median speed. Now, there is a method that we can apply that would help us answer this question. However, this is that type of question that you get in an exam that you're not expecting, you're not prepared for, and it's quite unusual. It's quite rare, this type of question. So rather than just bang through the question with a known method, I am going to problem solve this using the core knowledge of histograms and median, so that you've got an opportunity to just see how we work through problems when we don't actually have the method up our sleeve. Hope that makes sense. So as soon as I read that word histogram, I draw my formula triangle. It's just literally programmed into me. So I've got frequency density, and class width. Now I can see from the histogram that they've given me that my frequency density is here and my speed, which is my class width, is here. I don't have any values on this scale, only on this one, and I have no table, so I don't know what the frequencies are either. I can see that the frequency is found by multiplying the frequency density by the class width. So I know that the frequency is the area of these bars. Okay, so I can see it from the triangle, and it might be knowledge that I already have. But I normally need 2 pieces of information to find a third. What I can actually do in this situation is I can create my own scale, because even if, I'll show you what I mean, it'll be easier. So I'm just going to go up in ones because it's obviously the simplest scale that I can possibly do. So that's me going up in ones. I could label the entire scale. I could just label some key points. It doesn't really matter, okay? If I had doubled all of that, then all of my results as I work through the maths would be twice as big. But because the equations are equivalent, my answer would come out the same. So for that reason, I'm able to put my scale down, all right? As we've already said, the frequency is going to be the area. So I am going to be working out the height, and this one is 7.6. I am going to find the height of all of my bars, and I'm going to multiply it through by the width. So this one here is 2.5. This one here has a distance or a range of 7.5. Okay, so now I've done that step, I can see the number of cars in each of my bars, which means I can get a total frequency. So when I add those all together, I get 138.5. So there are 138.5 cars in my histogram. Now, I will find the median if I can go halfway into the data. Okay, so if I divide by 2, I will get 69.25. Now that is the position, remember, of the median. So the 69.25 car is the position of the median. Now I can see that the first 19 cars are in here. We've then got 70 here. So across these 2 bars, I've got 89.5 cars. So I know that the median must lie in this bar. I'm going to take away 19 from the 69.25, which is going to give me 50.25. Now, I know 70.5 is the total cars in this entire bar. What I want to do is multiply my 9.5 by something here that will give me the 50.25 that I'm looking for. And then this point here will be my median. Now, that's what we're working on. So I'll just get rid of all of that because that's just a bit of a nonsense at the moment. I will take the 50.25 that I'm after, divide it by the height of my bar, which will give me the width, 5.345. I need to go a full 5 in, which takes me to 60. And then I want to go 0.345 onto that. So the answer is 60 point, and just to 1 decimal place, 60.3. So I've used my knowledge of histograms and I've used my knowledge of median to help me work through this particular problem. Okay, so our last question. And for those of you that might be thinking of studying A-level, then this is really a big A-level topic. So if you can have all these basics really secure going into your A-level, you're going to find this topic a lot easier to access when you get there. Okay, so we've got a line that is a tangent to the circle at a particular point. Now, I would always get my diagram on the go at this stage. I don't know exactly how I might use it yet. I haven't even read the rest of the question, but I'm going to start getting a picture together of what I know. So this is the circle equation where the center of the circle is at the origin. So the first thing that I'm going to do is draw my circle. And I know that that center point there is the origin. So I'm going to mark that on. The line that is tangent is -3, 6. So I'm just going to kind of visualize -3, 6, that kind of thing. And I know that my line would probably be somewhere around here. I don't need accuracy. This is just a sketch. And I can pop on that point as well, which is -3, 6. An additional thing I can do is join up the radius to the tangent. And if we know our circle theorems, we know that creates a perpendicular 90-degree angle. So I will mark that on. And last but not least, I can mark on this information. They've told me that x squared plus y squared equals 45. 45 is my radius squared. So if I square root that 45, I have the radius. At this stage, I have no idea if that's going to be important, but honestly, it doesn't matter. I'm just building a picture. The line L crosses the x-axis at the point P. So I now need to get that x-axis on. So that's going to be a straight line through the center. That's gone on quite well. And that, therefore, is my point P. And before I do anything else, I can actually consider that coordinate. I already know something about that coordinate. If it's crossing the x-axis, then there is an x value. At this stage, I don't know, but I do know that the y coordinate will be 0. So it's worth putting that in as well. So I've built a picture of the information that they've given me. They want me to work out the coordinates of P. In order for me to do that, I'm going to need the equation of this line. The only information that I've got on this line at the moment is the point -3, 6. I either need another point, which I don't have in full, or I need a gradient, which I don't have. But what I do have on the perpendicular line of the radius here are 2 points. I've got the 0, 0. I've got the -3, 6. I can use that to help me. So we've got a gradient formula, which is y1 minus y2 over x1 minus x2. You're going to substitute in your coordinates, which gives -2. Now that is the gradient of the radius. Remember, our goal is to get an equation for this line, not really the equation of this line, but having that gradient means that I can use my knowledge about perpendicular gradients. So the perpendicular gradient is opposite sign and the reciprocal. So it would be a half. Now I'm going to use the formula for writing the equation of a line. It's not the only way to do this. So if you have a different way, that's obviously fine. You will see this formula at A level. I have in this formula a coordinate that needs to be substituted in, which is the coordinate on the line. And I have a gradient that needs to be substituted in, which is what we've just worked on. So I'm going to put all that information in now. And then you just simply tidy it up so that you get to the eventual equation. So that's our equation. Now, I know point P crosses the x-axis when y is 0. So I can substitute the 0 for my y. And then I can just rearrange to get x on its own. That gives me -15. So our point P is -15, 0. Okay, a couple of really tough questions in that paper. I hope you have found the solutions useful. Obviously, if you have, I ask it all the time, please like, please subscribe. Hopefully others will be able to find these papers. And yeah, I look forward to seeing you in the next video.